Mr. Madden's Math Minutes.
Sit back, relax, and get ready to learn. You give me 10 minutes or less, I'll give you a math lesson.
That's my dad.
Welcome to this quick lesson on measuring angles using a protractor. We're going to be measuring angles, and angles are measured in degrees. As you can see by the look of this protractor, it looks like half of a circle. And most protractors that you use will resemble this. So we're going to be measuring angles that go up to from 0 to 180 degrees. A couple of things to focus on before we actually use the protractor, if you recall from class. Okay, this area right here is going to be very important. Notice the line segments you see that form perpendicular lines here and here. Okay, that's going to be where we're going to be lining up the protractor with the vertex of the angle. Protractors usually have these perpendicular lines, okay, or they may also have a little hole right at that spot where the line segments intersect to show again where to line up the vertex. Another thing to think about is which way your angle is opening. Okay, you can see that there are two rows of numbers, one starting on the right hand side and going along the bottom. Okay, and that's really starting over here at 0 degrees and ending up over on the left hand side on this line again at 180 degrees. Or if the angle is opening up on the other side and starts over here, we're going to be using the outside numbers. And we'll look at an example of each, where this side will start at 0 degrees and will open all the way up to 180 degrees. You do see the numbers along here. Well, this is just measuring, length in inches, and right up here you have actually basically another ruler measuring in centimeters. We're going to be ignoring that and just using the numbers that go around the semicircle. Let's try it out. Okay, here is an angle. You can see that is marked in red. Now we're measuring, okay, this part shows you this is the inside of the angle. So the angle has been lined up with the protractor, and you can see on this protractor, this is where you have the perpendicular sides crossing, and the vertex of the angle is right here where those two rays meet. So that has to go with the center. Now the bottom ray, the one that I'm tracing right now, is lined up with this bottom line, and you can see it goes through 0 and 180. Now when you think about this angle, is this angle acute, right, or obtuse? We want to use right angles as our benchmark. Right up here we have 90, and this angle is not as big as a 90-degree angle, so it's definitely an acute angle. So my measurement has to be less than 90. So with this line, bottom ray lined up with 0, has to be 0 now, and the other ray, if I look at it, it's going right through 50 and 130. It's an acute angle, so it has to be less than 90, so I have to be using my lower numbers. So this is a 50-degree angle. Take a look at angle ABC. This angle is facing the other way. Okay, we're used to seeing angles that face this way, but of course we have to be used to angles that will face any direction, as angle ABC does. So again, we want to make sure, do we see that our vertex is lined up with the perpendicular lines here? Yes, it is. Do we see that the bottom part of the angle lines up with this black line which goes through 0? And do you see that we are going to be now using the outside numbers, starting with 0, 10, 20, 30, and so on. Take a look at this angle. Let's use 90 degrees as our benchmark. Is this acute, a right angle, or obtuse? Well, it's greater than 90 degrees, so it is obtuse. So now we're going to follow this line segment and see that it goes through 60 and 120. What would you think? It's obtuse, so it's got to be more than 90 degrees. So this has to be a 120 degree angle. Let's look at this interesting figure here now. We have multiple angles here, all that share the same vertex of M, right? So using that information, let's look at the measurement of different angles. Let's just look at angle AMB, which basically follows this line. Okay, thinking about a benchmark of 90 degrees, it is an acute angle. And if I line up again, my vertex is right here at the center where we have crossing perpendicular sides or lines, lining up the bottom part of the angle on this black line with 0, and then looking where this line goes through. And if my protractor is too large, I can always line up the straight edge with this side and extend the ray, because rays go on right indefinitely, so I can see where the ray goes through the protractor. And here I know it's less than 90 degrees, less than a right angle. It's going right through 30. So angle AMB is 30 degrees. Angle AMC, okay, is again an acute angle, and you tell me it is 50 degrees. Now let's look at angle AMD. Of course, is lining up with 0 degrees here, 90 degrees this way. So of course it is exactly a 90 degree angle. Angle AME, we have our first obtuse angle, right? It's going to be larger than 90 degrees. So when I look at when it goes through this part of the protractor right here, I'm looking at 60 and 120. It's got to be more than a right angle, more than 90 degrees. So that means it is a 120 degree angle. And finally, angle AMF. Once again, that is an obtuse angle, more than 90 degrees. So when I see here it's going through 140 and 40, right, I know I have to be using the bottom numbers because that's greater than 90 degrees. So angle AMF is 140 degrees. Now all these angles measured to a 10. These are all multiples of 10. You know, sometimes you will have angles that will measure in between, and you can see all the marks in between, right, the tens. Each mark is a 1, and each longer mark that's halfway between each of the tens, of course, is a 5. So you have to be very careful when you're lining up your protractor and reading where the angle, the line segment or the ray is going through the protractor. Alright, hope this helped. You can watch the video again or ask your teacher the next time you see them. Take care. This is Mr. Madden saying thanks for watching. I hope it helped, and whatever you are, be a good one.